Yeah.
Okay, at the end of class, when I let everybody go, you hold on, okay? Because I want to talk about your quiz.
Thank you.
You're welcome. All right. So I need exponential and logarithmic. Open. There we go. Put that back on. All right. So solving exponentials and logs. Okay. Our objectives today: solve exponential equation, solve logarithmic equation, eventually model and solve real-life problems with exponential and logarithmic equations. That's what we will be doing Friday and Monday. All right, today and tomorrow we'll just be working on exponential equations. You can borrow as many as you guys need. Just make sure you bring them back. Okay?
Thank you.
No problem. All right, so basically what we're going to do is two things. What? Dude, you had a half an hour to write down three things. Get your glasses checked, son. Why are you wearing glasses if they're not going to help you see? What's the point?
I'm good.
You good? Sure, buddy. I yelled at you a little bit there. I'm sorry.
I can't see because it's fogging up.
Is the mask?
Yeah.
That I completely understand, which is why I don't wear my glasses when I'm driving, which is a bad thing. Because I should be wearing my glasses when I drive, but when I do, then same kind of thing. So I got you. Smell what you're stepping in. So when we rearrange the desk, you need to be in the front next week?
No.
Where is this paper? Come on, Jada. Every day. Let me see.
Sorry.
No, you're not. No, you're not. All right. You're probably right. Whenever this Jada does it, it's usually something I did wrong. She's more conscientious than I am, which is my problem. All right. Solving equations. Now you're going to make me find it. Yeah, luckily we're not in a rush today. Where the heck is it? I had it yesterday. Oh, 3.4 notes, 2021. All right. I can't wait for regular school. There we go. Okay. Up now.
Thank you.
Anytime, Jada. It's my fault. All right. Okay. So back to this. So we're solving. I've yelled at people. We're good to go now. All right. So we let off with our objectives. Everybody's got that. All right. So we got two types of equations. One-to-one equations when both sides of the equation in the same format or can be written in the same format. We use one-to-one properties. Okay? And then inverse properties, well, we use exponentials and logs in order to solve. All right? So here's the examples. 2 to the x equals 32. Here's what I want you to do. In the box that says reworking, rewrite 32 as a power of 2. So rewrite 32 as a power of 2. All right. So 2 to the x equals 2 to the what power? 5th? Okay, here's what I want you to do. You good? Cross out the 2's. What are you left with? What equation? X equals, you're done. That's it. So x equals 5. For those of you planning on taking either the SATs, the ACTs, or a college entry exam, make sure you're aware of that. Don't make your life harder. All right, when you can rewrite them with the same base, the bases cancel out. When you have any equation where it's the same thing on both sides, boom, get rid of it. Okay, so the next one, log 4 of x minus log 4 of 8 equals 0. Do me a favor, I isolate the log 4 of x by getting the log x of 8 on the other side. All right, so rework it so that the log 4 of 8 is on the other side of the equation. All right, and when you do that, what do you have? Log 4 of x equals what? Log 4 of 8. Good? Cross out the log 4's. What equation are you left with? X equals what? 8. You're done. All right, do the same thing with the one underneath. Do the same thing with the one underneath. X equals 3, correct? Everybody's good with that idea. Okay, the last one, dealing with fractions, you just have to remember that 1 over 3 is 3 to the negative 1. So raised to the x. All right, so we rewrite that 9 as what? 3 squared. Good with that idea? Power law says when we raise an exponent to another exponent, we multiply. 3 to the negative x equals 3 squared. Negative x equals 2. X equals negative 2. Okay. And that's it. Pretty straightforward, correct? Okay. Those aren't going to be the ones that trouble most people, but please don't get confused when we incorporate other things. Okay, so now for the inverse property magic, and this is where things get tricky. All right, it is your choice how you write it, because sometimes writing too many steps confuses people. So this is what happens. When we have an exponential, whether it's e or a number, or we have a log, we use the inverse. So the inverse of e is the natural log. So basically I do the natural log of e to the x equals the natural log of 7. All right? So the natural log of e to the x equals the natural log of 7. The natural log of e to x, because they're inverses of each other, cancel out, leaving us with just x. So x equals the natural log of 7. It is your choice whether you want to write that step or not. Sometimes that step confuses people and makes it actually work. All right? So what you can do, if you look at the one underneath, e to the x equals 10. If you know when you do it to the natural log, it cancels out, you can just write that as x. And then you can just say, okay, what is the inverse of e, the natural log? The natural log of 10. You have to decide what's best for you in terms of getting confused, because unfortunately this is a situation I found in years past, both teaching Algebra 2 and Trig, where people get more confused by writing it out. You got to choose what you want to do. Okay, and it's up to you completely what you want to do. All right, when they give you the natural log The natural log, the opposite of that would be e to the natural log of x equals e to the negative 3. So that's showing all the steps. We're raising both to the inverses of the natural log. Again, when we raise e to the natural log, just like when we do the natural log of e, they cancel out, giving us x equals e to the negative 3, and you're done. Those are exact answers. If it tells you to estimate, then you go to your calculator and you put in e to the negative 3. But if it wants exact, that's how you leave it. All right, you do want to isolate either the exponential or the logarithmic part, just as if it was a variable. So this is the same thing as 2 times y equals 32. How do you get rid of a multiplication by 2? Divide by 2. Okay, it's going to cancel the 2's out on the left, giving you 5 to the x equals 16. Okay? Now, this is different because it's not e. So now you need to use the log of the base of the exponent. So you're going to use log 5 of 5 to the x equals the log 5 of 16. All right. And once again, the log 5 of 5 to the x is going to cancel that all out, giving us x equals the log 5 of 16. And if it wants exact, you're done. If it wants you to estimate, you do the log of 16 divided by the log of 5 using change of base. That's why we reviewed change of base yesterday. All right. So this is exact, and this is estimate. Everybody good thus far? Anybody have any issues? Okay. So if you would please work on those two. Work on those two problems. Log 10 to the x equals negative 1. 3 to the x equals 15. Absolutely. All right. How are we feeling thus far? Make sense? All right. That is really the only new thing with this. Okay, I just lied. I called myself. That is the only new thing on this page. All right, we just have to apply it when they make things more complicated. So for example, 4e to the 2x minus 3 equals 2. All right, we're going to add 3. 4e to the 2x equals 5. All good? We're now going to divide by 4. E to the 2x equals 5 over 4. Now, as soon as you have an exponential that's isolated or a log that's isolated, that's when the inverse is kicked in. The inverse of e is the natural log. That will cancel out the e, and I got 2x equals the natural log of 5 over 4. If you want to write that as 1.25, feel free. How do you then get rid of the multiplication by 2? Divide by 2. My final answer is x equals the natural log of 5/4 over 2. That's exact. That's exact. All right, if it asks you to estimate, you then plug in to your calculator, natural log of 5/4. You then divide that by 2. So you first have to isolate the exponential or logarithmic part, all right? You then have to isolate the variable part once you've gotten rid of it. So please work on the one next to it. It's little buddy, 2e to the 2x plus 5. All right, now if you can do mental math, go at it. So in other words, how would I get rid of the plus 5, minus 5? How would I get rid of the multiplication by 2, divide by 2? E to the 3x equals 12. That's the only thing I would need to say in terms of work. If you want to show the other things, feel free, but in terms of work, when you get this assignment, if you show me that you've isolated E, that shows number one, you know you have to isolate E. The next part is the natural log part. If you know that I do the natural log of this, it cancels out, and I got 3x equals the natural log of 12. All right? All right, now be careful. How do you get rid of multiplication by 3? You divide, and x equals the natural log of 12 divided by 3, not 12 divided by 3, the whole expression. So as you progress, if it's an estimate, and you want to estimate that in the middle, if that's going to be easier for you, if it doesn't say exact, if it tells you to estimate, you can do the natural log of 12, which comes out to be about 2.485. You know what I'm saying? If it says to estimate, if that's easier for you. Okay. Good? All right, 2 more, and then we'll get you started on the assignment, because we'll do the other part tomorrow. Exponentials without base e. So we got 2 to the 3, 2t minus 5 minus 4 equals 11. This is your exponential part. All right, so we got to isolate that. We're going to add 4 and divide by 2. Everybody good with that idea and why we're dividing by 2? That's not part of the exponent. That's going to leave me with 3 to the 2t minus 5 equals 7.5 or 15 over 2. Your choice on how you want to write it. All right. My exponential part is now isolated, so I'm going to do a log. But it's not the natural log because I don't have e. It's the log base 3 of 3 to the 2t minus 5 equals the log 3 of 7.5. Again, if that's going to confuse you by writing that out, skip it. If you know that when I do the log 3 of 3 to the exponent, all that's going to cancel out, and all I'm left with is whatever the exponent is. 2t minus 5 equals the log 3 of 7.5. All right, so again, I would need to see that and that. Okay? And then to get rid of the minus 5, I would add 5. Get rid of the multiplication by 2, I would divide by 2. Boom. So it's that entire expression. The log 3 of 7.5 plus 5 divided by 2. All right, again, if it says to estimate and you want to estimate that in the middle, remember your change of base. That would be the log of 7.5 divided by the log of 3. All right, so to finish up instruction for the day, and then we'll talk about the homework, please work on that one. 6 to the 2 to the t plus 5 plus 4 equals 11. This is due on Friday, what I'm giving you now. All right, this is due on Friday. And under. Maybe over here. No worries. Sorry. You're welcome. Uh-oh. This is just the equation part. You're going to try and isolate this. So treat that like a variable. This is the same thing as y plus 5. How do you get rid of plus 5? And how do you get rid of multiplication? No worries. You're welcome. All right, those of you at home, I forgot to scan the homework, so that'll be up in about 10 minutes after the bell rings. I apologize. But you can still pay attention when we work our way through it. All right, so to get rid of the plus 4, we would subtract 4. To get rid of multiplication by 6, we would divide by 6. We'd have the expression 2 to the t plus 5 equals 7/6. Everybody good with that? All right, so then I would do the log base 2. That would cancel out the 2. T plus 5 equals the log base 2 of 7/6. And then how would you get rid of the plus 5? Minus 5. T equals log 2 of 7/6 minus 5. All right, if you're worried about confusing yourself, if you want to put that in parentheses, feel free, but it's not mandatory. All right. Okay, everybody good? All right, let's briefly talk a little bit about the homework. So numbers 1 through 8. All right, numbers 1 through 8. All right, are all examples of 1-to-1. What that means is the log on the left-hand side and the log on the right-hand side are exactly the same. So you can just cross it out from the very beginning. Now, the one thing you got to do, check, and we'll look at it with number 6. All right. And we'll talk about this at length tomorrow as well. Log 14 of m squared minus 5m equals log 14 of 7 plus m. So m squared minus 5m equals 7 plus m. They cancel out. That's fine. M squared minus 6m, when you bring the m over, minus 7 equals 0. They should all be factorable. factors into m minus 7, m plus 1 equals 0. Which gives me the two solutions, 7 and negative 1. However, what you then need to do is plug back in. So if I plug in 7, both sides give me 14. That's okay. I plug in negative 1, both sides give me 6. Still good. So they're both solutions. What you have to check for is if you plug one back in and it's negative, it's straight in. Because we can't get a log of a negative number. Okay? Everybody good? All right, if we look at 9 through 12. I don't know if there's another one on the other side that's like it. Yep, 13 as well. All right, so 9 through 13, all right, are also 1 to 1. You just have to get your exponents to be, the base of your powers to be equal. They're 1 to 1, but the bases have to be equal. All right, the bases have to be equal. And again, people at home, I apologize. I'll run copies of this as soon as I can. So what that means is if you look at like number 10, 36 and 216 are both powers of 6. So you first write 36 as 6 squared, keeping the negative x, and then 216 is 6 to the third. Don't worry about negatives with those because you can have a negative exponent. All right? Good? Okay. (14 through 21). Solve each equation. Round your answers to the nearest 10,000s. If you don't have a calculator, leave it in exact form. So if you don't have a calculator at home to do it, leave it like that. So for example, if you look at number 16, 2 to the r minus 1 equals 8. How do you get rid of the negative 1? Add 1. 2 to the r equals 9. All right? The base is 2, so r equals the log 2 of 9. If you have a calculator, it's good practice. Then go do log 9 of log 2. Get the estimate. If not, just leave it like that. Okay? If you want to start trying 22 through 33, it's fine. They involve properties. So for example, we're going to go through examples of these tomorrow. So if you look at 22, that's an addition. And when we condense, addition turns into what? Multiplication. So this would become the log 7 of 5 times 2 minus x equals the log 7 of 55. All right? Just so you know. We'll go through those tomorrow, but those involve the property. So if you can't get to them yet, fine. That's why you have until Friday to hand these in. All right? So you'll have until tomorrow. We're going to go through these and deal with exponentials. With 25, the only difference is it's division, it's subtraction. So that gets replaced with what? Division. But again, we'll practice those tomorrow if you want to go through. And then same thing on the other side. So that's completely up to you. You have the rest of the period to work on that. Jada!
Yes.
What happened?
Well, I was in the middle of taking my quiz and
Okay.
I couldn't hear anything. So then my family friend came over to fix my ear, and I was in the middle of the quiz and they didn't tell me what time they were coming. So I had 20 minutes left and then I had to leave the entire thing.
Okay, so how much time did you actually work on the quiz?
Well, I had 20 minutes left, so I think I missed
Don't just how much time did you work on the quiz? You saying you had 20 minutes left?
Yes.
So let's work on the math. If you had 50 and you had 20 left, how many minutes did you work on the quiz?
Yeah, I had 20.
You worked on it 30 minutes.
I said 30.
Oh! All right. So you need 20 more minutes. Is that what you're telling me?
I mean, I came back and I had like 10
Jada!
left. No, Mr. Shut up.
Jada, you need 20 more minutes.
Okay.
Is that what you're telling me?
I had time after, so I would say 10 minutes. I want to be honest with you.
And I appreciate that. That's what I'm trying to get to the bottom of. So you need me to redirect you 10 more minutes.
Yes, please.
Okay. I got to go talk to somebody about, because usually when I redirect, it's not for a specific time. So basically, let me talk to somebody at my lunch, and I will email you to tell you when it'll be open and that kind of thing and the amount of time you have left.
Thank you.
Goodbye.
Goodbye.
All right. I'm not presenting now anymore. I want to make sure it is. Stop presenting. Stop recording. Stop recording.